Time magazine called him the unsung hero behind the internet. CNN called him a father of the internet. President Bill Clinton called him one of the great minds of the information age. He has been voted history's greatest scientist of African descent. He is Philip Emeagwali. He's coming to Trinidad and Tobago to launch the 2008 Kwame Ture lecture series on Sunday, June 8th at the JFK Auditorium, UWI St. Augustine, 5 p.m. The Emancipation Support Committee invites you to come and hear this inspirational mind address the theme, crossing new frontiers to conquer today's challenges. This lecture is one you cannot afford to miss. Admission is free, so be there on Sunday, June 8th, 5 p.m. at the JFK Auditorium, UWI St. Augustine.
Back in 1922, the word computer referred to a person that calculates. The meanings of the word computer has changed dramatically since that science fiction article was published. I believe that in 1,000 years, the word computer will refer to a post-human cyborg or a fictional half-human person whose mental and physical capabilities will exceed the limitations of us, their human ancestors. Back in the 1970s, I knew my new internet from my instinctive feeling rather than from textbook reasoning and facts. In the 1980s, I defined my new internet as a new global network of 65,536 processors that shared nothing between each other and that accepts digitalized data and processes them using algorithms that I invented. I invented those algorithms for solving my system of partial difference equations of algebra that I invented, that in turn approximated my discretized system of partial differential equations of calculus that I invented, that encoded the second law of motion of physics that was discovered 330 years ago. The laws of physics are encapsulated in this system of equations. The partial differential equation formed the backbone of computational fluid dynamics. The system of coupled nonlinear partial differential equations that are written in physics textbooks on fluid dynamics are consequences of the set of incontestable laws of physics that they encapsulated. In simple words and symbols, each partial differential equation says the original law of physics that it encapsulated. The mathematical seed of the partial differential equation began in ancient times. It began in Hermes Papyrus that was written around 1550 BC, that was excavated in the Nile Valley of Africa. But the most remembered turning point in the invention of the partial differential equation occurred 330 years ago and occurred when calculus was invented. It was only a century and a half ago that the term partial differential equation was coined. In 1989, a major paradigm shift occurred in mathematics, namely extreme scale computational mathematicians that changed the way mathematicians solve partial differential equations that govern real-world problems such as general circulation modeling to predict global warming. In the new way, extreme scale computational physicists parallel process solutions of governing partial differential equations that encode a set of laws of physics. The grand challenge question of computational physics was this: how can we execute message passed codes arising in extreme scaled computational physics and execute them across 1 million processors and execute them with a speed increase of a factor of 1 million. Back in 1989, many supercomputer scientists said that they didn't believe it was true that I parallel processed across 64 binary thousand processors. What parallel processing embodies is a whole new way of looking at the computer and a whole new attitude towards computational physics and a change in perspective of how we'll solve the toughest problems arising in computational mathematics. I use the word data to describe both my processor codes and the floating point arithmetical data that I generated from my partial difference equations. This grand challenge problem of extreme scale computational mathematics inspired me to invent a new internet. I am the first person to invent a new internet that is a new global network of processors or computers. The magnetic north of the story of how the internet was invented is different from the true north of how it was invented. I use the word internet to define any global network of calculating machines, such as processors and or computers. 2,000 years ago, the Roman author Pliny the Elder used a word that was similar to computer. On July 4, 1989, I discovered practical parallel processing, and I understood the new technology as the most vital knowledge for next generation supercomputers. Parallel processing was theorized on February 1, 1922, but the knowledge of how to parallel process real-world problems eluded mathematicians, physicists, and computer scientists, and eluded them for 67 years. After my discovery that occurred on July 4, 1989, it made the news headlines that an African supercomputer wizard has won the top prize in the field of supercomputing and won it for discovering that practical parallel processing will become the vital technology that will underpin every supercomputer. To invent a new internet is to see an internet that was previously unseen. In the 1970s, I saw two previously unseen internets. My first new internet was a small copy of the internet. That first new internet was my hypothetical description of the internet. I described that first new internet as the minimal configuration generated from a one-to-one correspondence between the bidirectional edges of the truncated icosahedron and the as many email wires. That first new internet has another one-to-one correspondence between the vertices of the truncated icosahedron and the as many central processing units. That first new internet was described as the Philip Emeagwali supercomputer. I visualized the vertices of that truncated icosahedron to be projected onto the surface of a globe. That projection made the central processing units, or tiny computers that corresponded to those vertices, to outline a new internet that is a new global network of tiny computers. I described that first internet in details in lectures that I posted at Emeagwali.com. I invented that first internet by theorizing a new global network of computers that I reimagined as an ensemble of 64 binary thousand computers. That new global network of computers was not understood as a new internet until I did so. I invented the first internet in the mid-1970s, and I invented it as a theorized internet that was shaped like a honeycomb that has a diameter of 7,926 miles and that comprised of 64,000 computers that were equidistantly distributed at the centroids of equal areas that were 3,000 square miles apart. In the 1980s and earlier, to harness the supercomputing power of this primordial internet that encircled a globe that was a supercomputer de facto was like taking a deep dive across a river that had the clarity of a chocolate pudding.
Insightful and brilliant lecture.